got X is in L1 and Y is in L2, right? Never sort those. Then how do I get the line of best fit and the R? Where do we go?
To stat calc 4.
Stat calc, can't go wrong. It tells you the one that's got the line in it. 4. L1 is my X's, L2 is my Y's. Calculate! Who got the closest to that? Who thinks they got the closest to the right hand? So the slope is supposed to be negative 0.88, basically.
I think I got the closest.
What'd you get?
I got y equals negative 0.9167x plus 21.334.
Dude. Anybody beat that? No, okay. So it was sort of a luck of the draw kind of thing, right? You just happen to draw the line a certain way. I'm okay with mine. I'm a human. Now, we knew ahead of time, looking at this data, would you say this data is strongly correlated or weak or what?
Strong-ish.
And what tells us that it would be strong?
R.
No. That will verify it, but how can I tell just by looking at it, looking at the data?
How far away the points are from the line.
Okay. So the line is pretty well tight to the points. I like to think of it as the data being tight to the line. Right? They don't stray too far away from the line. And that gives us two things not surprising. It's negative, which makes sense, it goes down. And it's pretty close to -1 because it's pretty close to perfect. It's pretty good. Is that cool? Is this coming back? It's been a little while. Okay, how do I get this to show up on my calculator screen? Where do I go to put the line of best fit? I can do it two ways.
Stat plot?
Well, not stat plot, but y equals.
Oh, yeah.
So put y equals, let me see if I can remember now. Let me get rid of this. Negative 0.88x plus 20.5, is that right? I've already forgotten what the hell it was.
20.495.
Sure, 20.5 is fine. Now, if I hit graph, it's going to be kind of disappointing. What did I forget to hit? Does anyone remember? Whenever I put new data in, I've got to somehow tell the calculator to find it. Does anyone remember how to tell the calculator to freaking live up to its price tag and find that data? It's under Zoom somewhere.
It was negative 0.88x.
I put 20.5, just rounded it. Yeah. But if I hit Zoom, and of course I want Zoom stacked. Oh, of course I did this earlier. I turned off my, everybody should still have theirs on, but I turned mine off earlier. Good job. Now if I hit Zoom stacked, it should find it. Let me know if you're doing all right. Is everybody able to get that? Okay. So that's kind of the idea. So now if I wanted to predict, and of course the idea here is the more you study, the less mistakes you should make. This is some shit I made up, which is why it's such a good fit. If I did this in the real world, it would probably still have a negative slope to it, but it wouldn't be this nice. What was I about to say? Done it. Oh, the fact that this correlation is pretty strong, does that mean that if you study more, you'll definitely make less mistakes?
No.
Nope. I don't know if I've said this yet, which is kind of funny because I'm trying to say this less, but at least say it once. The fact that two things are correlated says nothing about causation. There could be one that causes the other. There could be the other way around. It could be a third thing that causes both of them. It could be a coincidence. It could be a complete coincidence. There's a whole website called Spurious Correlations where it talks about the cost of butter, Wisconsin, versus the number of beavers that died in Illinois or something, and it just happened to be coincidentally correlated, you know? And it's like, what did butter do to beaver? You know, so you're like, whatever. Kind of give up on it. It's just a coincidence. So There's so many things that have to happen after that. This one, we feel pretty good about. Yes? You study more, grades are going to go up, which means you're making less mistakes. Okay, that makes sense. Okay. Blah, 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 blah. Okay, good. Answer this last one. So, on the other side, holy shit. You're going to have fun with this. This is something that you would see from me on a test. Some real shit. So let me tell you this. I really want this to make sense. When we do a correlation study, don't we create our own equation, right? You guys agree with me? Didn't we just create a freaking equation from a line we drew? Yes. So here's the nice thing. With percentages, we don't have to make them decimals. Keep them as percentages. Because we're making the damn thing. We're going to make an equation that you can just plug a percentage in. Because we're making the shit, yes? So put into L1 your, now, are we really breaking ground here? Does it make sense that there should be a correlation between the percentage of bachelor's degrees in a state and the median income? Should there probably be a correlation there? Maybe? Okay. Now the causation is a different thing. You would think that bachelor's causes income to go up, but maybe income goes up, which means more people can go to college. Or maybe it's a little bit of both, right? So, go ahead and do it. L1, L2, and then try to answer all the questions as best you can. Feel free to help each other out a bit as you go if you want to, or if you don't trust these people near you, just, keep them away. Finally giving in to my age here. Oh my God. Sorry. make sure that you're able to, well, that's exciting. It's gonna be an exciting part of this video. Make sure you're able to get the scatter plot and the line of best fit to show up, because on the test, you're gonna have to come up and show me that. No, didn't go to. It's probably gonna be in your line equals, yeah. So there's like that's a minus sign, not a negative. So just clear that out. Negative. Put the new line this way. Probably haven't calculated it. Okay, so you're good. Wait, sorry. So just so you know what to expect. That's what I got. Oh shit. There we go. Anybody else get those numbers? Okay, thank God. Just to remind you guys, if you wanted to, I mean, you can still go in and put it in manually, the y equals. But to remind you guys, when you go to calculate this, it's got this question right here. If you have the newer calculator, and you can just tell it, okay, put that into a variable, put that into a y variable, put that into function, put that into y1. So now it calculates it, but now it's also, the line is in y1. So now you just have to hit the right zoom button, and it should show up beautifully. Do a throwback question real quick for you guys while you're doing this. Why do you think I had to use median there? Why, if I use something else, why would it not make as much sense? Does anyone remember why sometimes it's better to use the median? Anybody? If you have a set of data. what would tell you it's better to use the median rather than the mean?
What about outliers?
Outliers. Remember? You get that one company where you have people making some money and then you got the boss and you're like, what's the average? The average would be completely off for what to expect to make. Because the one outlier is huge. So if I used mean incomes, screw it, man. The people at the upper echelon would just dragging all those averages up. I got to use median for this to make sense. Okay. So this is exactly what I told you I would do. I'm going to tell you what R has to be enough evidence that there is correlation. So obviously we kick this thing's ass right there, right? We're way the hell past that. But interpret R means, is it weak negative? Is it strong positive? Is it whatever? So what is this tell me about the correlation?
Strong negative.
Why negative?
Oh, wait, I'm sorry, strong positive.
Okay, strong positive. Strong because it's close to 1. Positive because it's positive. All right. What does it tell us about the line of best fit? So that's a weird question, but there's one answer I definitely would expect from you. The other one, I don't know. But anybody? What would the fact that my R is strong positive tell me about the line of best fit?
Positive direction.
Okay. I like it. Be more specific though. That's the positive part. What about the strong part?
All the points are close around.
There you go. Good. The points are close to the line. Another acceptable thing is I would trust the equation to make predictions. And that came up, 5 billion years ago, otherwise known as before Thanksgiving. We talked about that real quick. I would trust the equation to make predictions because my R is pretty good. But normally, if I were you, I'd just say the data points are close to the line. They're not on the line, but they're close. Now, how do I do this part C? Anybody do this part C yet?
Yeah.
Yeah, because in this equation, what does Y stand for?
Money.
Money. And what does X stand for?
Percentage.
Percent with a bachelor's? Okay, I like it. So if I know the percent with a bachelor's, I can predict the amount of money it's going to make, right? Or the median income. So it'll be Y is 1570.74 times, what do I put here?
37.6.
Yeah! Because we created an equation that can handle percentages, and then you just do that shit, right? Let's see what we get here.
Did you just take a random data point?
What do you mean?
Oh wait, never mind.
No worries. So I get 71,291.32 cents, rounding down like the bank would. Now, why do I say compare to Virginia? Why does Virginia relate to this question, part C?
Virginia is the same thing.
What do you mean the same thing?
Virginia also has 37 points.
Yeah. So we've made a general prediction for any state that had that 37.6% bachelor's. And then we can specifically see, okay, how good was that estimation? Well, would you say it was pretty good?
Yeah, it's pretty close.
Because it's actually 71,535. It's pretty damn close. So why isn't it perfect? Why didn't it come out with the right number?
I mean, it's just math. Sometimes things just don't end
Oh,
up
man.
the same way.
Now that one,
There's
Steph's
plenty
the-
of other reasons.
it's just math, Jeff. No, so that's sort of kind of it. But what's built into this? I mean, the equation we used. What's its job? Its job is to try to get as close as it can to all the data points. So why in the hell would it also go through any specific data point? Who knows? So the real question is, why is it so close? So we know it's probably not going to be exactly the right number because there's going to be wiggle wobble. It's not going to go through every point. Okay, but that's pretty close, yes? Why is it so close? Why is the estimation that good?
Really strong correlation.
Yeah, R is freaking big. R is almost 1. Strong correlation. Okay. Maybe? Is this, you guys doing all right? Okay. And then finally, of course, the question you should always expect. Do your results mean that if you get more people in a state to earn a bachelor's degree, then the median income of that state will increase? Is that what that means?
No.
No. Exactly. Because it could be the other way around. It could be a totally different variable causing things. And if you just throw bachelor's degrees at people, which is what it seems we're starting to do, that doesn't mean they're going to suddenly make more money, right? Okay, maybe. Maybe. Okay, not too bad, right? No. Because, all right. So, that's chapter 12. So just get in there and try that stuff out. I want to go a little bit over, I want to introduce some of what we're going to talk about. Wow, it's really early, and I don't care. Because we're going to get out relatively soon. Let me see, I can grid on this here. Yes. I'm going to go on the board script. I'm done with this projector business. Sebastian, can you? Thanks, man. Yes.
So the text for the homework, sometimes like the textbook has different. Should we know of any different?
I'm sorry, buddy. All the way on. That's my fault. Go ahead, sorry.
Should we know any different symbols, or do they use the same symbols?
Oh, good point. I understand that. You're like, I don't really trust you anymore, Jeff. I don't blame you. No, you're fine. You didn't say that. I said that.
Like is R like some other?
No. R's are.
Okay.
The Y might have a hat on it, if I remember correctly, which I actually agree with. It's kind of funky if they do. Let me see if they do that. Did the Y in the line of best fit? The Y might have a hat on it. Where are you? Dadgummit. There it is. Yeah, okay, good. All right, this is kind of nice. I appreciate that question. It's a really good question to ask in general, because I often forget exactly what the book's about. This is one where I'm like, I should have done a better job, because this is how I was taught, little Y hat. So this would be the line of best fit. And the little hat dude means exactly what we just saw. The answer we get is an estimation from a sample. So like P hat is the percentage from a sample. You guys with me? When we just plugged 37.6, did we get the correct Y? No. So I'm not going to put Y there. I should put Y hat, meaning it's an estimate from a sample. Maybe. The crowd goes, man. I think that's the only difference in notation, in symbols used. Yeah. Okay. And again, as always, if you see something weird in the book, just bring it up to me, because I sometimes forget little things the book does. What we're about to get into. Does anyone remember what I said? Why did I skip chapter 11?
So you could give us a break.
Give you a break from what?
T-scores and Z-scores.
True, but it's even worse than that.
You have a new one.
We have a new chart, right? I didn't bring it today because I'm not going to get that far. So let's talk about why a new chart should exist. What kind of problems will we be doing that require a new chart? So let me ask you this. Z and T both relate to what shape for most of the problems we use? Z and T scores relate to what shape? No, definitely not. What kind of distribution? Normal, correct? So, is that roughly normal?
Yeah.
Yes. Is that roughly normal? Yes. Is that roughly normal? Yes. Are they the same shape? Not really. What's the biggest difference between the three?
Spread.
Spread, and be more technical, standard deviation. So, I really want this to make all the sense in the world. When I'm analyzing means, when I'm analyzing percentages, I can calculate standard deviations, correct? Yes? So then, if I can calculate the standard deviation for all the samples, I know what the shape of the distribution is. Yes? So the main thing that governs the shape of a normal distribution is the standard deviation. Yes? So like if I was here, this is 5 and this is 6. How do I say this? Sure, I'll let you. How much is in here versus if this is 5 and this is 6. See how there's a lot less in there, yes? Because of course standard deviation is smaller. So the standard deviation tells me how fat or skinny it is, kind of gives me the shape, which leads to different areas. Of course, if I smoosh it all in there, standard deviation is small, most of the areas in the middle, not much out there, yes? So what if I had a problem where I actually wanted to, instead of doing like a hypothesis test for a mean, or something. Oh, sorry. Right. Oh shit. Oh shit. So hypothesis tests are coming back. Oh baby, you've missed them. I know you have. Instead of doing a hypothesis test or even a confidence interval, maybe these, I'm not going to make these come back big time, but this will come back. Confidence interval. What do we make confidence intervals for? How many confidence interval formulas do we use? You guys remember? Does anyone remember anything about any of the confidence, anything? When's that final? Oh yeah. You know, like I can use a formula sheet, man. I've got that shit in my head. Anything. They all have a plus and minus. Yes? That would be acceptable. Somebody tell me anything else. What could go right there? How many options are there for what goes right there?
2.
2. What are they?
Percentage and vehicle.
Yes. And then, of course, there's a z-score, yes? Or a t. Right, for this one. Screw this guy over here. And then there's going to be the modified standard deviation, right? We'll do this. And, of course, there's a whole t and s. Who gives a shit? And then this one is going to be the freaky dude we had to create. I don't even know. You guys probably have put that out of your memory. I don't blame you. It's traumatic to go through watching equations get made. It's kind of like watching hot dogs get made. You never want to eat another hot dog. Okay, so what does this have to do with anything? All this shit here relies on this. Yes? Yes? Completely.
If it's not normal, you can't do it.
Yeah, if it's not normal, you can't do anything with it. But also, if it is normal, if it looks like this, the answer to these things is going to be very different than if it looks like this. Yes? Is that very basic, right? Okay. So what if, instead of a hypothesis test about a mean, or a percentage, or instead of a confidence about a mean or a percentage, what if I wanted to create a confidence interval or do a hypothesis test on a standard deviation itself? What if somebody had a claim and you're like, just kick that guy out, Jeff, and forget about the damn thing. Nope, too bad, he's here. And he's got a claim that the standard deviation of something is not 2. Right? No, it's never going to happen in my life, Jeff. Right, it is right now. Okay. Can I use, it's a very obvious answer, can I use the same method before? Can I use the same picture? Because the picture we were using before had to know what this was to be created, yes? So if now I'm like, I think the standard deviation is not 2. That kind of infers that we don't know what the shit the standard deviation is. And in fact, even better. Before. Let's see if you guys really get this. Do you remember alternate universe Florida? Or does that bring back bad memories? Or does that bring back any memories? Anybody remember ALF, Alternate Universe Florida? Okay, I didn't call it ALF, but I should. When I make this picture, am I not plotting X bars? Remember that we plot the means of the samples and stuff? Okay, I like it. And of course, the standard deviation of those things ends up telling me how fat or whatever this is going to be. So what I need is a similar picture created, but for these kind of things. Where will it fall? What will it normally look like? And what happens is, all right, what is the main formula we use? Or give me one of the formulas we use to find where things fall in here. That's a very vague question, and I love it. What do we calculate to figure out where something falls? What's the fourth step in hypothesis test? What do we calculate to see where our sample got? We can do it.
Z-score?
Yes!
Okay.
Z-star, right? Doesn't a Z-score tell you how far from the middle you are? Which tells me where I am in the picture, which tells me if I'm at a weird place or not a weird place, which tells me if I found evidence or didn't find evidence. Yes? Okay, so,
But you can't have Z-scores if we don't know standard deviation.
don't worry, that's why we're not going to use Z-scores. But there's an analogy here that I'm going to make. We've got these, remember these formulas, blah, blah, blah. We even have this one, p hat minus p over square root of pq over it. All these different frickin' formulas. We even had the one with the x bar 1 and the minus x bar 2 over the square root of sigma 1 squared. I don't even care. All right, so a bunch of frickin' formulas. They all fall in the same picture, yes? That's the beauty of making a z-score. Once I've made a z-score, it doesn't matter what the shit specifically I was talking about. I know exactly where it falls in the picture. No matter if it was a mean, seal, life expectation, or it was a percentage of people that like pumpkin pie before turkey, or whatever, right? Maybe. So once I make a z-score, it doesn't matter what it was at first. I can compare it to whatever else I want to in there. Okay, so what does it have to do with anything, Jeff? So now, I want to make something comparable to Z, but not Z. We're going to call it, because it is, we're going to call it this. This is called chi-squared. Right, it's not Dragon Ball Z chi, sorry, but it's just chi-squared. It is one symbol. You never square root it. Yes? It is one symbol. You never square root it. Okay, I like it. There are different formulas for it, just like for Z. Yes? Z scores correlate to this kind of picture for most of our problems. They actually don't have to be in a normal curve, but that's what they kind of correlate to for our problems, right? Chi-square scores are like z-scores. They correlate to this picture, and most of the things look like this. There's one situation where it doesn't look like this. They correlate to this picture. Can anyone remember how to technically identify that shape? And then I'll give you my very not technical way to identify that shape. Anybody remember what it is when you like have one side that looks like somebody pulled it?
Skewed.
Skewed?
Right skewed?
Yeah, right skewed. Okay, I missed the first part. Right skewed, right? I was thinking like taffy. Somebody pulled the taffy. Now, being the mega geek that I am, I see Jabba the Hutt there, right? Oh, thanks. This is my Jabba the Hutt distribution. That joke is for me. So I don't give a shit if you guys don't like it. It's my joke. I love it, and too bad. Let me give you, so again, I really want you to understand, right now you don't even know where that picture came from, whatever, but Z's relate to this the same way that chi-square scores relate to this. Now let me ask you, do you see how it has a hard stop right there? Can standard deviations be negative?
Yeah.
Can standard deviations be negative? No.
No.
But more importantly, so that's kind of like a surface level thing. This is actually, it's called chi-squared because it's a sum of a bunch of things squared. So it's definitely going to have to stop at 0. Do you remember what was nice about this? If I had negative 2.05 and this is positive 2.05, it was awesome because of the symmetry and all that. Remember that? You lose all that shit here for so many reasons. The middle isn't 0 anymore. Can't be because there's 0, yes? Also, this goes further out. It's not symmetric in the first place. Okay, that sucks. Too bad. All right, right? But that's just the thing to realize. So don't look for that because it's not going to be there. What's funny is I'm going to put a formula down here that I think makes more sense right now, and it's the last formula we're going to use, but I don't care. So here is a very kind of fundamental formula. It's just like these. There's other formulas. You with me? In different situations, that formula is going to be radically different.
Is that an S or a Y?
That's an S. Good point, though. How do I make an S not a 5? Maybe just overdo it. Is that better?
Yeah, that's a little better.
So it's like kind of.
Now it looks like a G shape.
Is it not the same thing as like degrees of freedom? Because it's
Oh, very good point.
It's one and it's like a
Right.
sample.
Isn't that degrees of freedom?
Yeah.
That's what you're doing. Yeah, I like it. So it's intimately related to degrees of freedom. So let me ask you this. If you take a bunch of samples, so how would I create this picture? I would take a bunch of samples, I would calculate the score, and I would plot it. Plot, 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 plot. Most of my samples should be, wouldn't you agree that if I take good random samples, shouldn't S be close to sigma? Maybe, yes, maybe, yes, no? So this, the mean of this, which is a little off from center, the mean is actually equal to the degrees of freedom. That's actually not very important. We're actually not going to use that fact directly, to be honest, but I might as well just put that down there. So some samples will have much, much larger standard deviations. Not as many will have smaller standard deviations. That's why there's a chunk down here, and then there's a chunk with big old outliers up here, yes? Because again, what's the smallest standard deviation that a sample could have? 0. Couldn't you pick 12, 13-year-olds? And what's the standard deviation of their age then? 0. Yes, but couldn't you also pick a 2-month-old and an 18-year-old and a 98-year-old and whatever, and you have this huge freaking standard deviation? Yes, yes, yes. Okay, okay. So once you feel a little more comfortable about why this shape is the way it is, right? We had a ton of time with this thing, and now we end up with not much time to talk about this thing. Kind of sucks. I agree. What else did I want to say? All right. Yeah, I didn't bring the charts with me. That's okay. I'll do that next time. So the very first thing we're going to do, this I think is in the last, I think it's in 11 point, I can't remember now, 6? Whatever the last section is, that's where that formula is. The very first thing we're going to do is, for example, real quick, this is the last thing I'll talk about, and then we'll head out early. Probably can't see this far. All right. For example, let's say there's 5 teams, right? 5 teams. And I look at the number of people with red shirts, right, on each team. So they all have the same number of people, and they just kind of look at the number of people with red shirts. I don't know why. I just do. So say there's, let's see, 60 people. Say there's 60 people. If each team got the same number, how would I say this? Oh, I got it. 60 people with red shirts. There we go. You already forgot what the hell you said, Jeff. I did. Say there's 60 people with red shirts. and each team got the same number of red shirts, right? Where are my Star Trek fans? Anybody? These are the people that are going to die in the away mission. No, okay. If each team got the same number of people with red shirts, how many would they all have gotten?
12.
How did you get that?
I did 60 divided by 5.
Yeah, of course. You have 60 total, and you have 5 groups to divide them amongst, right? So if I expected them all to get the same number, if I expected them to have a uniform distribution of red shirts, they would have all had 12, yes?
Okay.
But then I go, okay, you with me? So we're like, let's say that they're all uniformly distributed, right? Which is something, if you just randomly selected teams, wouldn't you sort of expect that to happen to a degree?
Well, yes.
Would you expect, if you randomly select teams, would you expect 3 teams to have nothing but red shirts? No. Right? Okay. So you kind of expect that it should be close to this. So let's say I see this team had 10 red shirts, this team had 17, this team had 2. I got to add it to the right thing, don't I? This team had 18, where am I now? 20, 30, 40, okay, good job, Jeff. Okay. I think that's right. We'll pretend like it's right. What's your gut tell you? Do you think this is evidence that it wasn't this distribution? So again, this is going to be related to a hypothesis test. I'm not going to make you do all the steps. Don't freak out. I'm going to make you do 2 of the steps. But what do you think it is? Why do you think this is evident? And again, let me say this. This is a sample, let's say. This is a sample. So you can't just go, well, it's obviously not because 10 is not equal to 12. I'm done. Thank you very much. Come back to my next TED Talk. No, it's a sample. So what is it that I have to find out to show evidence that the whole population is not uniform, right? I'd have to show that these differences are big enough. Everybody's like, shh, what the hell is that going to look like? Oh, all right. So if there were no differences, we would be here. If everything was exactly the same, wouldn't I get zeros when I look at all the differences? So that would relate to being right here. So what would be evidence that the population is actually different is something out here, a rejection region. So here's where there's no difference. How do I show that there is truly a difference? Not only does it have to be different, it has to be different enough. So we're going to have a chart with chi-square values, and we can look up what the chi-square, just like we did looking up a z-score to tell me where the rejection region was, right? We can look up the chi-square score to tell me how far I've got to make it, and then we're going to use not this formula, different formula, to figure out what the chi-square is for the sample, see if we made it far enough away. So the nice thing with this section, we don't get a lot of time to work with this, but the ideas around it are very familiar, so it shouldn't be as terrible as it could have been. And that's enough. That's enough. You see, you guys are all like, just stop. So I'll stop. So,